Hello students and welcome to the class on HVDC transmission and facts. I am Dr. K.D. Joshi from Bajaj Institute of Technology, Varda. This is the first lecture. This is a video on the subject HVDC transmission and facts as taught for the DBATU syllabus for the students of Bajaj Institute of Technology, Varda. So let me first of all take you through the course outcomes, what we expect at the end of this subject, what are your learning outcomes. So the course outcome is that at the end of this subject, learning this subject, the student should be able to understand importance, configuration and types of HVDC transmission. You should be able to analyze the operation of HVDC converter, system control and protection. To understand the concept of flexible AC transmission system, their role, type and functionality, and to analyze the operation of static series and shunt compensator. So in a nutshell, it is a first course which gives you an introduction to the advanced concepts in power system, especially power system transmission, that is the high voltage direct current transmission and the flexible AC transmission. So why we are learning this subject? We are learning this subject in order to solve the problem of power flow control. All of you must have taken a course in power system operations, and by now you must be available to the understanding of this particular equation, which is P is equal to E1 E2 sine delta by X, wherein what is E1 and what is E2. So here we are trying to showcase the power system simply by two generators. So this is an area where you have surplus generation, and this is the area where there is less generation and a load is there. Loads are at both the ends, but this is the surplus generation area and this is the area where there is a deficiency of power. So naturally what will happen, that the power will always flow from the higher area towards the lower, or wherever there is a surplus, from there towards the deficient side the power will go. While power goes from one point to another, it has two paths which are shown here in this case, and the two paths are the two transmission lines, we can say. One of the path is having an impedance of X, whereas the another path has twice of X. So if I consider this as line 1 has an impedance of X, this line 2 has an impedance of 2X. So what happens, as you are aware about the electric current, if you have a low resistance path, okay, if you have a low resistance path, higher current will flow from that path. So if you have two resistances which are in parallel and one resistance is R, another resistance is 3R, naturally what will happen, more amount of current will flow through this first resistance R. So same thing is applicable to impedance as well. So we consider that the line is mostly inductive, that's why the impedance is shown as X. So if the line impedance is X, then higher amount of power will flow through that line impedance X, whereas less amount of power will flow from the line with impedance 2X. And what will be the ratio? So by common sense you can arrive at this: 2/3 of power will flow from the first line, only 1/3 of power will flow from the second line, wherein power is given by this equation E1 E2 sine delta by X, okay, where E1 is the voltage at this end, at the surplus end, E2 is the voltage at this bus at the deficiency end, delta is the angle between E1 and E2, and X is the reactance of the line. Okay, so with this problem of power flow control, what is the problem? So I have already told you that this is how the power will flow, but where is the problem? You will have a question that where is the problem exactly? Okay, so the problem is in this, that we are not able to control the power flow. So let us say that I want both these lines to carry equal amount of power. I want that this line should also carry P by 2 power and the lower line should also carry P by 2 power. If the total amount of power is P which is entering here, I want that both the lines should carry equal amount of power. But we are not able to do that. Why we are not able to do that? Because the power flow is dependent on the impedance of the line. Okay. Now this is just a two transmission line network which is shown to you, but in reality the power system has n number of lines which are connected in all kinds of topologies, and the power keeps on flowing in this way just based on the impedance. Of course, we have some level of control by using the tap changer at the substations. We have these transformers, tap changing transformers. To some extent, we can manage the value of E1 and E2. To some extent, we can manage the value of del. However, we cannot control the power beyond a particular value. Okay, so we want a mechanism by which we'll be able to control the power flow as per our desire, as per our will. So if I insist, let us say that if this line is capable of carrying the entire amount of power P. Okay, first of all, we have to look at the capability as well. So if I assume that both the lines are capable of carrying entire power P, then I should be in a position to send entire power P from the first line, or entire power P from the second line, or half of power, or 1/3, 2/3, or whatever combination which I desire based on my requirement, based on as a user or as a controller. I want the amount of power to flow in a particular transmission line as per my will, not as per the transmission line impedance. This is the problem which we need to solve. This is the solution that we are aiming at. And to get to this particular solution, we have two options which are available with us. What are these two options? So one option is we can go for the high voltage direct current transmission line. One option is we can go for the high voltage direct current transmission line, okay, or the HVDC line as it is known popularly. In this line, what I can do is I can connect a set of power electronic devices which is called as a converter. Okay, this is called as a converter. Now this converter is connected at two ends. Okay, deliberately the symbols are shown in a different way at both the places. Okay, so basically they are converters. So what they do is they will convert the AC which is coming at one end, and they will make it into a DC. So the AC which is coming at this point will be converted to DC at this point, and then the power will be transmitted in the DC form over the long distance. Again, the DC power will be converted back to AC, okay, and it will be given to the load at the other end. And this can be done in other direction as well. Suppose you have the more amount of power on this side and less amount of power on this side, then we can convert the AC on this side to DC. The DC current will flow in this line, it will reach to the other side, and it will be converted back to AC and will feed the load on the other side, right? So what we can do is we can send the power from one end to another end in the DC form by using a set of converters at two ends. These converters can work as a rectifier. You know what is a rectifier? Which converts AC into DC. So these converters can work as a rectifier, or the converters can also work as inverters. So inverters means they will convert DC into AC. So either you convert AC into DC or you convert DC into AC, and both these converters can be controlled in such a way that if you want, zero power can flow through this transmission line. If you want, entire power P can flow through this transmission line. So another simple example we can take. Let us say that this is the power surplus area. Okay, so I am denoting this by S. This is the power deficient area. I am denoting this by D. Let us say that the amount of power which is given from this end is 1000 megawatt. Okay, and right now the HVDC line is so adjusted that it is going to carry 500 megawatt. If this line is adjusted to carry 500 megawatt, 1000 minus 500 will flow through this AC transmission line. So this line will carry 500 as well. Okay. However, I have a control over these converters and inverters. I can make this line in such a way, I can make the firing angles of the converter and inverter in such a way that instead of 500 megawatt, this line carries now 700 megawatt. If this line will carry 700 megawatt, this line will naturally carry 300 megawatt. Okay. Or I can make this line to carry only 100 megawatt. I can make this line to carry only 100 megawatt. Then the upper line will carry 900 megawatt. So this is what is the control that we are talking about. You can control the transmission line, HVDC line, from 0 to 1000 megawatt, and by default the other line which is in parallel with that, the AC line, will also be controlled from 0 to 1000 megawatt. right? So this is one way we can control the power as per our will. Now another way is, once again you come to this equation. What is the other way? The other way is to handle the AC part of it. So once again you come to this equation E1 E2 sin delta by x. So what we can do is, we can vary this x, we can control this x by connecting a series impedance which is variable in nature. Okay, so let us say that the reactance of this line is x. I introduce a variable impedance which is varying here, and its value changes from 0 to minus x. Okay, so if I have x here, which is the line impedance, and if I have this variable impedance which varies from 0 to, let's say, 0.5x, okay, and its value is negative in the sense that it opposes the impedance of the line. So line impedance is x, and this impedance can vary from 0 to 0.5x. So if I make this 0, the line impedance will remain x. If I make this 0.5, the line impedance will reduce and it will become x by 2. If I make this 0.1, the line impedance will become 0.9x. So this way I can control the impedance of the line. This way I can control the impedance of the transmission line, and by virtue of controlling the impedance of transmission line, the power can also be controlled, right? Or I can do another thing. I can vary the value of this delta, okay, by introducing a phase angle changer, right? So I can introduce a phase angle changer like this, and I can vary the value of delta. So by using either HVDC link or a mechanism by which we change the value of x and delta, we can control the power flow as desired, right? So I hope that you have understood the need for power flow control, because ultimately we want to control the power as per our requirement, right? And we are also able to do this using HVDC or by using this technique. Basically these two things which are shown here form the basis of the FACTS technology. These two techniques which are shown later on form the basis of the FACTS technology, right students? So this is another example which makes the concept more concrete what we have studied earlier. Okay, so again here you see, if you have a power of 2000 megawatt, generator of 2000 megawatt here, 1000 here, and there is a load of 3000 megawatt here, right? And there are three lines. This line has a 10 ohm impedance, this has 10 ohm impedance, this has 5 ohm impedance. If you apply KCL and KVL, you can solve for yourself and see that the lines will carry different amount of power. So this line will carry, this line AB will carry 600 megawatt, line AC will carry 1400 megawatt, and line BC, this line will carry 1600 megawatt. Okay, now line BC is rated at 1250 megawatt. That means the maximum power that this line can take is only 1250 megawatt. Okay, however now it is loaded at 1600 megawatt. So this line is overloaded. So we can solve this problem by introducing a minus 5 ohm impedance here. Okay, so if I add a minus 5 ohm impedance, this is 10 ohm, this is minus 5 ohm. So the line total impedance, the new impedance of this line will become 5 ohm. And now you can see the power here is 250, here it is 1250, here it is 1750. All these powers are less than the maximum rating as specified here. Okay, so line AB maximum power is 1000 megawatt. How much line AB is carrying? Only 250, which is below 1000 megawatt. Okay, line AC, it is 1750 megawatt. Line AC maximum power is 2000, so it is below that. Okay, line BC is carrying 1250 megawatt, and which is the rating of the line. Okay, so the line is carrying its rated power. So by introducing a impedance, we can do this. Okay, or we can add a 7 ohm inductor in this line and we can achieve similar results. Or we can add a minus 4.24 degrees of phase angle and we can achieve the similar results, right? So what we are basically doing is, and how do you introduce this minus 5 ohm, plus 7 ohm, minus 4.24? This can be done using the FACTS controllers. Alright students, so I hope that you have understood the problem of power flow control and what are the two solutions for this. We will continue this discussion in the next class, actually when we will talk about the HVDC. So first we will be beginning with the HVDC part, wherein we will see these things which are shown in this slide, and later on we will move to FACTS controllers. So these are the contents. Thank you so much for your patient listening to the class. We will continue in the next class. Thank you so much.